Welcome back. This is our last learning target of the unit, so that's really exciting. We're going to be graphing, kind of switching gears from doing all this algebraic work, and we're going to switch to doing some graphing work. So we're going to graph linear inequalities in this lesson. That takes us back to Unit 3 where we talked about inequalities. So let's review that for a second because I know that it's been a while. So after today's lesson, we should graph linear inequalities and write them given a graph. Let's review what inequality looks like. So in example 1, it says, is x equals -2 a solution to the inequality 4x minus 6? Reminder that this symbol is a less than symbol. So I'm going to go ahead and take this x equals -2, and I'm going to replace it with the x here. So 4, remember when we substitute a value in, we put it in parentheses, -2 minus 6 less than 10. 4 times -2 is -8. Bring down the -6, and we're going to simplify again. -8 minus 6 is -14, less than 10. Is -14 less than 10? Yes. So that means yes, -2 is a solution. That's how we plug something in to check and see if it makes sense. If we were to plug something in and we got a number bigger than 10, then it would have been no, that value doesn't work. It's not less than 10. It can't be true. It doesn't make the equation true. So how do we graph an inequality? That again is review. We're going to go ahead and first solve this inequality. So it's just like solving an equation. Draw your line, try and get x by itself. These cancel. I have 2x. Bring down the greater than symbol. Reminder that that is a greater than. 13 minus 5 is +8. Divide both sides by 2. The 2's cancel. Bring down that greater than sign, and 8 divided by 2 is 4. So I get x is greater than 4. When I graph this on a number line, I can either use an open circle and draw my arrow to the right because it's greater than, or I can use that parentheses and draw an arrow. So remembering that that is how we graph on a number line. Okay, we're going to do a second one because now we're going to use another symbol that this one is a greater than or equal to. Now this is the exact same problem as before. These two problems are exactly the same. So I'm going to go ahead and save a little bit of time and say, okay, I know the solution to this is x is greater than or equal to 4. I'm just using a different symbol. I'm using the symbol that matches in each one. So this was a greater than, and in the second example, it's a greater than or equal to. When I graph a greater than or equal to, I use either that closed circle on the value and go to the right, or I can use that bracket and go to the right. Either way works. So what is the difference between these two graphs on these two number lines? Well, one graph, the first graph, I'll say the first solution, does not include 4. The second solution does include 4. That's a really important distinction when we work with inequalities. I can say something is greater than 4, that doesn't mean it is 4. In the second example, I'm saying that x is greater than or equal to 4, so 4 is included. And we designate that with either parentheses, open circle, or bracket and closed circle. This is going to become really important when we're now going to switch to graphing inequalities on a coordinate plane instead of on a number line. So what we've been doing so far is this number line, right? If I have x is less than 1, that's either an open circle on 1 or a parentheses on 1 and going to the left. Now we're going to start looking at what happens if we graph it on a coordinate plane. So if I switch now to a coordinate plane and say x is less than 1, notice that I've got this line here, x is at 1. And I am putting all of the shading here, all this dark pink, wherever it's shaded, are all values that are less than 1. Okay? I don't want to put any values over here because all of those values are greater than 1. And we don't want that. We want all the values less than 1. So we're going to really focus on how to graph these lines on coordinate planes, and we're going to focus on where do we shade, and noticing that this line right here is a dotted line, and that is because we don't include the 1. We make a dashed line when we don't want to include it. So I've given you a little chart here that shows you the 4 different inequality symbols and how we shade and whether we make a dashed line or a solid line to show, hey, this value is included, but this value is maybe not included. Okay, so if I've got a greater than symbol, I'm going to shade above the line. If I have a less than symbol, I'm going to shade below the line. So that's where I'm shading when after I draw my line. Okay. Now I'm going to flip from the rows to the columns. If I have in fact, let me show this better. If I've got this line here, that's meaning that I need to make a solid line when I connect my points, when I do my rise over run. If I am missing a line here, this line is missing, I'm going to say no line, then that means we're going to make a dashed line or dotted line. So this is your little chart to help you remember, and as you practice, it will become easier when you get used to it. So let's look at the next example to kind of show how we're going to use this. Example 4 says graph y is less than 2x plus 3. So remembering that this is like y equals mx plus b, so we're going to graph it just like y equals mx plus b. The 2 here is my slope, and the 3 is my y-intercept. So I'm going to go to my graph, my coordinate grid, and I'm going to plot that y-intercept at 3. Remembering that this, I'm going to erase this part here, that this is the same thing as 2 over 1. So I'm going to go up 2 over 1 to the right because I want my line to be positive. And I'm going to keep making points that are up or down 2, left or right 1. And now before I connect it, I'm going to go to my inequality sign and ask myself, does that have a line under it or no? It does not have a line under it, so when I connect it, I'm going to connect it with this dashed line. So when you're graphing these, I really need to see whether your line is dashed or solid. That's important. I also know that if it's a less than sign, I need to shade below the line. So I'm going to look to my y-intercept right here. Okay, and that value is 3. What numbers are less than 3? Are they these numbers here, that 2, that 1, that 0? Or is it these numbers up here, 4, 5, and 6? Well, numbers that are less than 3 is all of this shaded below. Okay, and you want to shade the whole grid if it helps you even. I've seen this done before. You can draw little arrows that say, hey, this is where I am shading. And that's okay too. I don't, either way you want to show it is fine with me. Okay, so that's what your graph should look like. You just need to lightly shade. You don't need to go crazy and shade super dark, especially if you want to erase it if you've made a mistake. Then the question says, name one coordinate pair in the solution set. The solution set is the shaded region. Let me write that a little nicer. So it's in the green. So I could say this point is a point in the shaded region. This point works. This point works. So I could say 2, 0, 3, -1, or 3, 2, etc. Any coordinate pair that is in the shaded region. Okay, so that is a coordinate pair that is inside, that is in the solution set. Well, what's a coordinate pair that is not? Oops, I meant to use the highlighter there. That is not in the solution set. So not means in the unshaded area. So now I'm going to look at maybe this point right here, this point here, maybe here, any of the points that are in the unshaded region. So -3, 1, -2, 3, -4, 3, etc. are not in the solution set. Okay, so any of those coordinate pairs, if you were to plug them in, they would make that inequality true, that it's in the shaded region. Okay, so I want to show you an example of what all the different options are for the same graph. So notice that each of these graphs is the same problem. Let me get the right color. So -1/2 x plus 3, that's the problem for all of these. Okay, so we're going to graph it like we would in y equals mx plus b. So y, negative 1/2 x plus 3. 3 is my y-intercept. And negative 1/2 means I'm going to go down 1 into the right 2 or up 1 into the left 2. And I'm not going to connect my dots yet. So I'm going to go ahead and do this on all 3 of these first, because all 3 represent the same coordinate pairs along the coordinate grid. Okay, remembering your positive and negative lines, remembering what we've talked about earlier in this unit and how to graph these. Okay. So now the question is, where do I shade and do I make a solid or dotted line? That's going to go to looking at the symbol. So that is a less than or equal to. So I'm going to go ahead and connect this with a solid line. Draw my arrows. And less than sign means I shade below. The next one is just a less than sign. So I'm going to go ahead and connect that with a dotted line, a dashed line. And I'm shading below still because it is a less than symbol. The only difference between those two is I make one dashed, one dotted. Okay. The next two, now my symbol is just a greater than sign, and it's not, doesn't have an equal to it. So I'm going to go ahead and make that dashed. And now it's greater than, so I'm going to shade above. And then lastly, I've got this greater than or equal to sign. So I'm going to go ahead and connect those dots. And I'm going to shade above because it's got the equal to. So these are all the same lines, but they've got different specifics depending on the inequality symbol. Okay, so those are the important things to look out for. I've got a couple more examples, and I want to focus on a couple things, remembering how to graph lines. So we're going to look at examples A and B first, and the directions just say graph each linear inequality. So for this first one, I'm going to remember that I've got an invisible 1 here, and that slope will be negative 1/1. I like to draw that in because I like to know what my rise and my run is right away, and sometimes those invisible ones can be tricky. I'm starting this graph off at the 5, so there's a point at 5, and I'm going to go down 1/1. Remembering that when you graph, you want to make points that go all through the grid. Am I going to connect this with a dotted line or a solid line? I'm going to connect it with a solid line because there's my inequality. Oops, I didn't mean to use the highlighter there. Connect it with a solid line. Draw your arrows at the end. This is a less than sign, and so I'm going to shade below this line here. Okay. Example B has got a greater than symbol. I've got a starting point at -1. Again, using that highlighter. Starting point at -1. And now my slope is 2/3, and I want to make a positive line. So I'm going to go up 2/3 to the right. Keep making points, down 2/3 to the left. And then I'm going to connect this with a dashed line because it doesn't have the equal to at the end. Now I'm going to shade above because that's a greater than symbol, and we shade above with greater than. Okay. The last two examples are a little bit different, and I've left you some space here because notice that these are not in y = mx plus b form. So for these, you have to get into y = mx plus b. So for this first one, I'm going to go ahead and solve for y. So I'm going to do example D first. So we're going to go ahead and go to D first. So I'm going to draw my line. I'm going to get rid of the 6x on both sides because I'm trying to get y alone. Those cancel, and I've got 2y. Now bring down the less than symbol. Put the -6x in front because it's mx plus b, and it'll help you with your slope. Now we want to get y alone, so we're going to divide everything by 2. The 2's cancel, and now I've got y is less than. -6 here divided by +2 is -3x, and 12 divided by 2 is 6. So this right here is what I'm graphing. So that has to be your first step to get into y = mx plus b to make graphing easier. I'm going to plot my first point at 6. remembering that this is negative 3 over 1. So I'm going to go down 3 over 1 to the right to make my line negative. And now I've got to check. Am I going to make a dashed or a solid line? I'm going to make a dashed line. It doesn't have the equal to. Noticing how steep this is, it kind of can be hard to tell if which side is below or above. But again, go to that number 6 and ask yourself, is 5, 4, 3, 2, 1 numbers that are less than, or do I want 7, 8, 9, 10 that is less than 6? Well, numbers less than 6 are 5, 4, 3, 2, 1, etc. So I'm shading here below the line. Okay, so that one just requires one extra step of getting y alone. For this last one, example C, it starts off the same way. I'm going to go ahead and subtract that 3x on either side. The 3x's cancel. Reminder that this negative gets brought down with the 5y. Carry down the less than or equal to negative 3x plus 10. And now here's the trick with this one that does trip students up. I'm going to divide by negative 5, and we've got to remember from Unit 3 that when we divide by a negative, there's a negative down here, what do we have to do with that inequality symbol? We have to flip the sign. So now, instead of a less than sign, I'm going to have a greater than sign. The negative 5's cancel out. I have y is greater than. Just keep this as 3 over 5x. If you need to put that in your calculator, negative 3 divided by negative 5. But also getting used to that idea of a negative divided by a negative is a positive. Remembering that to make it a little simpler. 10 divided by negative 5 is negative 2. So now I have my inequality I can graph. I'm going to start at negative 2. Up 3 over 5 to the right. Down 3 over 5 to the left. This is going to be a solid line because it's got the equal to underneath it, and I am shading above the line because it's greater than. Okay, so that covers graphing linear inequalities versus graphing on a number line. You need to be able to do both. Like always, if you need help or unsure of a problem, please ask for help, and good luck.